Good morning, good evening, good afternoon, wherever you are. My name is Vishnudat, and we are into our session number three. Session number three of Multicast from Scratch. And you all already know that we are into the journey of learning multicast, right? And here is the agenda of today's session. Today's session, we are going to continue our discussion on multicast at layer 2, and I will be letting you some important multicast addresses, right? Then we will have a look at it that how a host is going to show interest to the multicast stream. What is the meaning? The meaning is if I have a particular laptop or maybe a PC, and if this PC wants to hear or wants or shows interest in a particular multicast stream, right? How it is going to show that interest? It is going to be very, very interesting discussion. Okay. And believe me, there is a protocol which exactly does that. And the name of the protocol is Internet Group Management Protocol. And we will try to understand why behind IGMP, right? As I mentioned, it is to showcase the interest of a particular router or a host towards a multicast stream. What is the meaning? If you don't get it, that is perfectly fine. But this is the agenda. This topic is in agenda of today's session. As you all know, the terms are important. We will be introducing some multicast terminology today. And if time permits, we will see everything on Wireshark, whatever we learn, right? And believe me, in Hindi class, we could just cover till point number 4, and I'm pretty sure that point number 4 or from point number 1 to point number 4, it is going to take maybe approximately 1 hour, depending on the questions, right? So if you give me next 1 hour of your complete concentration, believe me, these topics are going to be with you for longer period of time. Having said that, without wasting any time, let's move to the first board where we are going to introduce some important multicast addresses, right? So what do we have here? We have a source here, and maybe the source address is, let's say, 10.10.10.10, right? And it is sending a multicast stream, maybe a new song of a movie, right? And this multicast stream or the data reaches here, and this data is going towards the multicast address, which is 239.1.1.1. And you all know now that 239.1.1.1 is going to represent not a single host, it is going to represent group of hosts because we are talking about multicasting, right? But where these hosts are or where this group of hosts lie, nobody knows. Even the source doesn't know where are the receivers. Believe me, it has a song, it has its source address, and it knows where exactly to send it. It knows that we need to send this song or this multicast stream to 239.1.1.1. Suppose this stream reaches here, right? How the packet is going to look like? First thing first, we are going to have data, right? What is the data? This data belongs to this song data, right? Or maybe the packet or a little data from this song. And then we are going to have what? We are going to have source IP address and destination IP address. You all know the source IP address is going to be 10.10.10.10, and multicast addresses are always the destination addresses. So we are going to see them 239.1.1.1. As simple as that, right? So basically this router, maybe this router is R1, it is going to get this packet from this source, and now this router has to decide, right, whether it needs to send this data to 0/1 interface or not, right? But one important thing is that router will send this data because we have only one interface or one network connected to this router, which is this gray network. If any of this host is interested in 239.1.1.1, then router has to deliver this packet over 0/1. And believe me, how this router understand that there is at least one host in this gray network which is interested in 239.1.1.1, right? How this router know about it? It is going to be interesting story, believe me, right? So here I just want to show just want to show you that on this layer 2 network, if this router want to send this data, router should understand that there must be at least one host which is interested in this communication, which is interested in this stream. And I am showcasing you two hosts. These yellow hosts are the hosts who are actually interested into this stream, and they started listening on 239.1.1.1. Now, this number, this IP address is not representing one host. It is representing set of hosts or group of hosts. Maybe any other host can also listen on it, 239.1.1.1. And in the last class or last two class, I give you a little bit idea that there are some application which can present a link to you, and you can click on that link. And if you click on that link, then basically you are going to get this 239.1.1.1. Basically your NIC is going to listen on 239.1.1.1 also, as simple as that, right? But we need to understand it is totally uh, you can understand this, that okay, this host knows that it needs to listen to 39.1.1.1. It is interested in that. This router knows that it needs to send it already received a packet for 239.1.1.1, and now it needs to send it, right? But it needs to be sure that there at least some host which is interested. It means that this host should be able to communicate it should be able to communicate its interest, right, to this router. Otherwise, how would this router knows that it needs to send this packet, right? As simple as that. And believe me, this is what we are going to study today, how this host can be able to communicate to this router number one, that it is interested in 239.1.1.1, right? By default, if I talk about a switch, if this switch is not intelligent enough, whatever the router is going to send it, it is going to flood it, right? Because switch will understand any multicast address as a broadcast address. And the reason is, just try to understand, as I mentioned several times, doesn't matter whether it's an IP address or it's a MAC address, right? Whenever you see them, it is always going to be destination address. Don't believe? Just have a look at it. When the source send this message to our 239.1.1.1, the IP address of the source is the unicast address, which is 10.10.10.10, right? But it is sending this message or this stream to 239.1.1.1, which is the destination address, right? And destination address is the multicast IP address. And suppose if this host is interested in this stream 239.1.1.1, it means this router has to send this packet on 0/1 interface. And if it wants to send this packet on 0/1 interface, it needs to put the MAC address on top of it. What should be the MAC address? The MAC address is going to be the source MAC address of this 0/1 interface, which may be, say, CCC. If I put CCC here, what should be the destination MAC And you should understand that the destination MAC is going to be the MAC address corresponding to 239.1.1.1. And we all know this now, how to calculate a MAC address or multicast MAC address from multicast IP address. In the last class, I mentioned that the MAC address is the 48-bit MAC address, right? Out of the 48-bit, starting 24 bits are reserved, which I mentioned 0001 and I think 5e, right? The 25th bit is 0 and the remaining 23 bits are taken from the IP address. It means that anybody can calculate the destination MAC address if they know source or if they know multicast IP address. Suppose after the calculation you get the IP address as x.x.x. Suppose, right? If that is the case, this message is going to be delivered to this switch. And from the switching fundamental classes, we all know that switch learns MAC address on the basis of source MAC address of the frame. What is the source MAC address? Of course, CCC. Switch is going to learn, suppose this is the 0/1 interface of the switch. Switch is going to say CCC is connected to 0/1. Believe me, in switch cam table, you are never ever going to see the entry for the multicast MAC address. And why? Because multicast MAC address is always destination MAC address in the frame. You are not going to see it as a source address, and switch learns its cam table on the basis of source MAC address. Very, very interesting. If that is the case, switch is never ever going to find the destination MAC address in cam table. And if that is the case, for this switch, every multicast message or frame is going to be unknown message, right? Or unknown frame. And what does a switch do with unknown frames? It is going to flood them. And you can argue with me that Mr. Vishnu, if that is the case, if switch has to always broadcast a multicast message or frame, then why on earth we are learning the layer 2 or multicast at layer 2? It should be efficient. It should not be delivered to all the hosts. Believe me, we are going to deal with it. But I am just informing you. Somebody has asked this question in the Hindi class also, right? I'm just informing you that switch will never see the multicast MAC address entry into its CAM table, because switch learns its CAM table on the basis of source MAC address in the frame, right? But yes, your question is genuine that yeah, we need to improvise. We need to make this process more efficient, right? But overall, the whole soul takeaway till now is that these hosts, the yellow host, should have some mechanism through which it can inform the router that yes, they are interested in 239.1.1.1, right? Or maybe a router should have a mechanism through which it can ask its network, this gray network, is anybody host interested in 239.1.1.1? Because I have a multicast stream for 239.1.1.1. If you're interested, I can send it over this gray network. As simple as that. But two addresses, two multicast addresses are really, really important. The one is 224.0.0.1. Actually, it represents every host in your network. Doesn't matter if it is a router or if it is a PC, laptop. Every host is part of 224.0.0.1 group. What is the meaning? The meaning is, if you consider this laptop or any laptop which is capable of doing TCP/IP, what is the meaning? It means that it is having all those 5 layers. application layer, transport layer, network layer, data link layer, and you all know physical layer, right? If that is the case, then in this TCP/IP stack, the developer of TCP/IP have written that if this host is up and running, it is actually listening all the times at this multicast address 224.0.0.1. It represents all hosts, right? Similarly, this router is also listening on 224.0.0.1 because we identify every host through this multicast address. Inside in this router, if you open and if you check, every interface of the router, whatever the IP address it has, it also listens at 224.0.0.1. What is the meaning? The meaning is if this router wants to send a message to all hosts on this network, it can send the message to 224.0.0.1. Okay, just have this address somewhere in your mind. Similarly, there is another address which is 224.0.0.2. It is another interesting address. It represents all routers in your network. If you want to send messages specifically to routers only, it means a device which is capable of doing routing. It means a device which can take message, which can take IP packet, see its destination address, and do the routing on the basis of the destination address, right? It must be listening on 224.0.0.2. That is the address which defines all routers. It is as simple as that. And by the way, the scope of these two addresses is only one network. And what is the meaning of it? The meaning is absolutely simple. Suppose I have this network, and inside this network, I have these two routers, router number one, router number two, right? I have one switch here also, and two host number one and host number two are connected to it. Routers are also connected, right? If this host is sending a message to, suppose this host has created a message and the IP address of this host is say 10.10.10. Say 10, and it wants to send a message to all the routers. It is going to send this to 224.0.0.2. What should be the IP packet looking like? IP address will look like, IP packet will look like this is source MAC, sorry, source IP. This is going to be destination IP. Source IP will be your 10.10.10.10. Destination will be 224.0.0.2. If this host wants to keep the packet on this wire, it needs to have, of course, source MAC, destination MAC. Source MAC will be A, maybe the MAC address is AA, and the destination address you can calculate. You can calculate the destination address on the basis of this multicast IP address, and maybe after calculation you will find the multicast MAC address is x.x.x. What is going to happen, guys? This message will be placed on this switch. Right now, the switch is not multicast aware, right? Because it CAM table doesn't have the entry for this MAC multicast address. As simple as that. But we will make it multicast aware. Do not worry about it, right? So what it is going to do, it is going to send it to this guy. It is going to send it to this guy and this guy. When H2 receives this message, it is going to say, it is going to see that the message is for XXX. And of course, this is a host. This can listen to 224.0.0.1, but this is not listening at 224.0.0.2. This is all host address. This is only router's address. And of course, there is a multicast MAC address corresponding to it, which is XXX. And this host is not listening at XXX. As simple as that. But if you talk about R1 and R2, this message will be received by R1. The destination of this message is 224.0.0.2. Because this is router, TCP/IP guys has written or hard coded into this router that you have to listen at 224.0.0.2 as well its corresponding MAC address, which is XXX. When this message reaches here, R1 is going to open it, right? Interesting. But as I mentioned, that this packet cannot go out from this router into some other network. And the reason is you all understand that the IP packet or the IP header doesn't have only source IP and destination IP. There are some other fields also. And one of the important field is time to live. And this time to live is actually the loop avoidance mechanism at layer 3. What is the loop avoidance mechanism at layer 3? You all know that we have spent a lot of time in understanding spanning tree protocol. But here at layer 3, we do not have any loop avoidance mechanism, right? Although individual protocols have some mechanism, right? But believe me, there is a field called TTL, and the highest value of this TTL can be 255. If a router receives an IP packet with TTL value, say 5, it is going to check its destination address and forward it. But while forwarding, it is going to decrease the TTL value from 5 to 4. Every router is going to decrease the TTL value by 1. It means that if a packet is having 255 TTL value and the packet is revolving between R1 and R2, suppose R1 is sending it towards R2 and R2 is sending it towards R1, right? What is going to happen? The packet is generated by R1, it will be reached at R2. R2 will be sending it back to R1, but this time the TTL value is going to be 254. Next time, and maybe I'm just letting you in case where the loop is there in the layer 3 network. Next time R1 send it towards R2, it is going to be 253, then 252. Eventually, it will become 0. The router at which this value becomes 0, that router is not going to forward this packet. And that is how you are going to stop the loop in layer 3. It is right there in the IP header. You do not need to build a separate protocol for the loop avoidance at layer 3. As simple as that. And by the way, guys, if you send a packet, as I mentioned, the scope for these 224.0.0.1 and 0.0.2 is actually only single network. It means that when you send a packet, the TTL is going to be only 1. And when this packet reaches at R1, if it wants to route it, it needs to decrease the TTL to 0. And TTL value 0 cannot be forwarded anywhere. As simple as that, right? So the takeaway from this board, whatever we have discussed till yet in the starting 25 minutes, right? It is very, very simple. That there are two addresses which we need to concentrate on. 224.0.0.1, all host. All hosts are actually listening on it. And then 224.0.0.2, which is for all routers. And I believe you must have heard about some of the IP addresses, right? Like 224.0.0.5 and 0.6. These are OSPF speaking routers, right? The scope is only one hop. It means that if R1 and R2 are running this protocol, basically these messages with these multicast addresses can go only one hop away. As simple as that, right? let's move to the next board now to understand. Just wait a minute, guys. Okay. Yeah. So now I have introduced one more router here. Everything is same, and I have introduced actually one more network here. Here we have the green network, and here we have the yellow network, right? This is the source having the IP address 10.10.10.10, and it is sending a stream to 239.1.1.1. Maybe it is having a film song, right? This is a video song. And now, whatever the packet this host is making, you all should understand that basically it is going to have the data, as I mentioned in the previous board also. It is going to have source and destination IP 10.10.10.10 and 239.1.1.1. It will be here at this router R2. But how this packet, the data packet or the stream can reach to R1 and then how R1 is forwarded towards R2, it is actually under the scope of multicast routing. Why? Because this is a multicast packet. Why? Because its destination address is 239.1.1.1, which is the a multicast address. That is why we are saying multicast packet. And if a router is able to forward a multicast packet on the basis of this destination address, it means that it is doing multicast routing. And from tomorrow class onwards, right, we will be talking about this thing only, how a router is going to forward this message which is having 239.1.1.1 or multicast as address as destination address. But till now, or for now, you just presume this message reached to R2, and now R2 needs to decide whether it has to forward this message to gray network or not, whether it has to forward this message over this green network or not, right? As I mentioned, that there must be some mechanism. If in a gray network, if only one host 239.1.1.1, if only one host is interested, this router has to forward this message over this white wire, as simple as that. Maybe in this network there could be 254 hosts because this is slash 24, and out of 254 hosts your permanent employees are 50, suppose, and these permanent employees wants to listen this song or CEO presentation or CEO's message. At least if only one of them say that 239.1.1.1 is something in which I am interested, because this router is having only one interface in this network, router has to forward this message only if one host says that it is interested. It doesn't need to be informed by these 50 hosts, right? These 50 hosts, if one, out of these 50 hosts, only if one host says to this router that I am interested, this router has to forward this. As simple as that. Similarly, if you see on the left hand side, right, on the green network, I don't see any yellow host. So the convention is whatever the yellow host I have, they are interested in 239.1.1.1. And they have shown their interest. How? That we will be talking about the next board. How this host are going to inform this router, or how router is going to ask that whether somebody is interested in the gray network in 239.1.1.1 stream or not, right? If you see on the left hand side, this green network, right? There is no host which is interested in 239.1.1.1, right? So nobody is going to inform this router that I am not in, I am interested, right? Nobody is going to say I'm interested. And if that is the case, router is not going to forward this message. It means the source will be forwarding this message to R2. How? We need to study. We need to understand multicast routing. But if router has decided that there is at least one host, it will be sending this multicast stream into this network, but not in this network. And basically, the rules through which these routers understand that on which network they need to send this multicast stream is actually your protocol, which is known as IGMP, Internet Group Management. Why? Because it is actually managing your groups, right? What is the meaning of group? Group means a multicast address because it is representing the group. And this protocol is going to say to this router that Mr. Router, on 0/2 interface, somebody is interested in this group. You need to send this message, right? So what we have done is we have given this task to our extremely important character, which is Mr. Rahul. And Mr. Rahul is now in charge of developing IGMP. So first of all, presume that there is no IGMP protocol at all till now. This will gives you this will give you the flexibility to think anything, right? Now you are the protocol developer and you understand why we need a protocol, right? You understand that we need to inform the router, or router can ask this network who is interested in 239.1.1.1. If somebody is interested, then I will be sending it, otherwise not. Who is going to do this communication? You should understand if there is a communication between two parties in computer networking, it means they are talking over certain rules. And if they are talking over certain rules, that thing is known as protocol, right? And here the protocol name is IGMP. And now Mr. Rahul is actually demonstrating you how this protocol is going to work. So first thing first, now presume you do not know anything about IGMP. Let's see what is going to be the approach of Mr. Rahul. In the meantime, I can see there is a question from Mr. Arun. Mr. Arun, you can ask a
Yeah,
question. Mhm.
yeah. Vishnu, actually, it's regarding the host. Host should notify to the router that okay, I'm interested in this particular multicast.
Yeah,
So how is he going to send the packet to the IP address 224.0.0.2 or one? Which one?
interesting. And believe me, Mr. Arun, this is the whole soul point of next to board. We will be discussing
Oh,
only this thing. And thank you so much.
okay,
And you have proven just now that we are going at the correct path, because if you are asking the question of next board in the previous board, it means that we are going sequential. Thank you so much. Having said that,
okay.
let's move to the next board where I will be making sure that Mr. Rahul answering Mr. Arun question. Why Mr. Rahul is building IGMP protocol, and see the thought process of this guy. Unfortunately, I have to again redraw this packet on this board, right? The packet is very, very simple. We have this data, right? Data from this source, which is 10.10.10.10, which is sending towards 239.1.1.1. By the way, guys, even this source doesn't know what are the various hosts which are interested in 239.1.1.1. This source is just sending the message towards 239.1.1.1, and here is the IP packet. Source is going to be 10.10.10.10. Destination is going to be 239.1.1.1. As simple as that. This message reaches from source to R2. How? As I mentioned, I will be letting you know in the 6th, 7th, 8th, 9th, and 10th class. Believe me, right? But for now, just presume that basically this data reaches to R2. This IP packet or IP multicast packet reaches to R2. Now, you all know the problem statement. How will R2 decide that whether it has to send this packet to green network or not? Whether it has to send this packet to gray network or not. So Mr. Rahul is suggesting rule number one because he is creating the protocol. That is why he is building the rules. He is saying, right? He is saying that R2 will ask a question or query, right? And this query is going to be that is somebody interested in 239.1.1.1? Very, very interesting. Basically, this message is known as IGMP message. By the way, IGMP is a layer 3 protocol, which is at network layer, right? And of course, IGMP is a protocol, so it has created this message. And this message needs to go to both of these networks, the green network as well as gray network. You should all agree with me this, right? So IGMP protocol, Mr. Rahul is developing, and Rahul is saying that this router, whenever it receives a packet, right? It is receiving a packet 239.1.1.1. How? We do not know. We will study about it, but it has received 239.1.1.1. Now, router is curious. Who on my networks, who are my net directly connected networks, or which host in my directly connected network is interested in 239.1.1.1? So if he's curious, he's asking the question in simple query message. So this message is created by this protocol, and now we need to send this message to both gray and green network. And I would like to showcase you that if you want to send this, because this is a layer 3 protocol, guys, IP works at layer 3. So we need to put the IP header. The source of this is going to be who is generating this message. This message is generated by R2. This message is not generated by the source. Source has sent its message towards R2. R2 has this message, this multicast message is already there, right? But to deliver this multicast message, before that, a router wants to understand where it needs to send it. So it is the source IP address is going to be interface address of 0/2, which may be, suppose, which may be say x dot x dot x dot x, suppose. And what should be the destination? Destination should be that this message should reach to all the hosts in this network. And to identify all the hosts, you all know that we need to send it to 224.0.0.1. We should understand this. And that is why we are sending it to 224.0.0.1. Really, really interesting, right? And now I need to remove few things here. Uh, and the reason is because I need to draw the complete packet so that you can understand. I need to delete Mr. Rahul also, but that is fine. We can draw him later. So now this is my IGMP message, and believe me, guys, I will show you step by step all these things on the Wireshark 2. This is my IP message because this protocol is at layer 3. It needs to be encapsulated in IP packet. And now this router wants to place this on this interface as well as this interface too. So let's create from 0/2 point of view, because 0/2 address is say x dot x dot x dot x. And now if this router wants to place this message, the IGMP query message on this link, which is your Ethernet interface, we need to put source MAC as well as destination MAC. You should all agree with me, right? We have learned switching, guys. We know in and out of the packets. We know where we put what header. As simple as that. Source MAC address is going to be the MAC address of this 0/2 interface, which might be, say, CCC. If that is the case, source is going to be CCC. And the destination MAC address is going to be, right? Any guesses? Absolutely. The destination MAC address is going to be the MAC address corresponding to this IP address. And suppose that is y.y.y. You can easily calculate it, right? We have discussed about it that if you have an IP address, you do not need to, if you have IP multicast address, you do not need to do ARP, guys, right? ARP we did in unicast. Here, we can calculate the destination MAC address on your own, right? If we can, then I am presuming that address is y.y.y. And now the packet is completed. Packet will be going on this interface. Actually, this is frame. This will be received by this switch. And now, for now, I'm presuming this switch is not multicast aware, although we will learn it, right? It is going to see that this message wants to go to y.y.y, which is the multicast address, and switch cam table never ever going to have this multicast MAC address. It is going to flood it. It will be going here, it will be going here, here, and here. You all know that everybody is listening to 224.0.0.1, right? And on corresponding MAC address of 24.0.0.1, which is y. This host is listening also at 224.0.0.1. This host is also listening 224.0.0.1. Why? Because TCP/IP developers has written in their stack, right? You have to listen on it. Means they have calculated the MAC address also y. MAC address here is also y. This host also will be listening to 224.0.0.1 on y. As simple as that. If that is the case, every host is going to decapsulate the packet. Every host will be removing this Ethernet encapsulation, then this encapsulation. They are going to find inside IGMP message. Suppose this blue host is going to get the IGMP message in which it is written, are you interested in 239.1.1? Very, very interesting. And this host, because it is not interested, right? It has not joined that group. Which group? 239.1.1. Who has joined? These yellow host has joined that group. How? There are n number of reasons how they can join. They must have clicked on a link, and after that click on link, they might be started listening on 239.1.1 and corresponding MAC address, right? So actually, IGMP message is asking whether you are interested in 239.1.1.1, and if they are not, whatever the message is sent by router, it is going to be discarded by this host as well as this host. But what is going to happen next? This host is also going to get this complete message. They will be decapsulating, they will be taking it out from the Ethernet, they will be taking it out from the IP, and they are going to get the IGMP message. And there it is written, are you interested in 239.1.1.1? And they are interested in 239.1.1.1. If they are, they can reply, right? By the way, the first message which is sent by the router is the query message. And the host are sending the report message, and it is also known as membership report. What this host is going to do, just try to understand. This host is going to generate one IGMP message, and it will say, yes, I am interested in 239.1.1.1. Very, very interesting. What is this message? This message is IGMP message. And if this host needs to send this message, because this message is created at layer 3, it needs to put source IP on top of it and destination IP on top of it. What should be the source IP? Source IP address is the unicast IP address for sure, 10.20. What should be the destination IP address? Because this host is interested in this 239.1.1, it is going to say, I am interested in 239.1.1.1. Whatever the message, whatever the IGMP message has, right? It is going to put that this is the destination IP. What should be the source MAC and destination MAC? You should all understand if this packet needs to go over the wire, we have to put source MAC and destination MAC, right? And what message we are creating? We are creating the report message. Why? Because this host just got a message, the query message. Somebody's asking, are you interested in 239.1.1.1? And this host is saying, yes, I am interested in 239.1.1.1. And I will be sending the message. Believe me, this messages will be received by R2 and R2 just need confirmation from only one host. Doesn't matter if 50 hosts are interested or 100 hosts are interested. If any one host reply with the report that yes, we are interested in 239.1.1.1, this router is going to send this multicast stream over this wire. Consider the case in case of sorry, consider the situation in case of this green network. What is going to happen, guys? There we will be receiving this query message, the same message, right? But the source and source MAC address is going to be 0/1 interface address, and source IP is also from here because this router is generating it. If that is the case, this will be received here. Switch is going to flood it here as well as here as well as here. If that is the case, this guy will be opening it and finding the IGMP message which says, are you interested in 239.1.1.1? And this host will be saying, no, I'm not. This will discard this message. It is not going to create any report message back. No, because this host is not interested in 239.1.1.1. If that is the case, this host is also not interested. This host is also not interested. Router will never receive a report message for 239.1.1.1 from this green network. It means that router just decided it doesn't need to send the multicast stream on 0/1 interface, but it has to send the multicast stream on 0/1. Who is working on this protocol? Mr. Rahul. Mr. Rahul is saying, very, very simple. A router needs to do a query and host. If there are any who are interested in this query, they need to reply with the report message. As simple as this protocol is, right? Now, because I can see there are hand raises, so I would like to take a pause here, right? Please go ahead, Mr. Burak, and ask your question. And thank you so much for asking question. Yeah, Mr. Burak. Yeah.
Okay. Okay, thank you, Vishnu.
Mhm.
My first question is, uh, mm, what is the meaning of IGMP querier?
Yeah, that basically is a slightly advanced concept where we are having, so basically it is also possible that on a LAN network, right? Suppose this is my LAN network. So I am having two routers, router number one and router number two. And both of them are receiving the stream for 239.1.1.1. Here also 239.1.1.1. If that is the case, both of them can supply that stream to switch. So we need to define one router who can be sending this query message, and that is known as the querier. We will be talking about it later. Don't worry, Burak.
Hmm, okay.
Yeah,
In this example, I think the router is a IGMP querier, right?
yeah, yeah. You are right.
Hmm.
It is always a
So,
router who is going to send the query message. No host can send the
mhm,
query message. Router is always
I
going to
see.
send it. Yeah.
I see. Can a switch act as a IGMP courier also?
Absolutely. If this is a layer 3 aware switch, then it can. But if it is a pure layer 2, it doesn't understand the IP addresses, right? Whether it's multicast IP address or the normal unicast IP address. If it's a layer 2 switch, no, it cannot be. But if it's a layer 3 switch with IGMP capabilities, definitely it can be courier because it
Mhm.
can have multiple, you can say, uh, because two switches can be there on one VLAN or one network. Okay, but it's a good question.
Okay, maybe we should enable the IGMP courier feature on the interface
Actually,
VLAN.
it is on by. Okay, we will. If the question is more towards query, believe me, we will going to finish it tomorrow.
Okay,
But the whole soul
okay.
concept
Thank
is
you.
like this only, right? Now,
Mhm,
Mr.
mhm.
Arun, you can ask your question.
Yeah. So, Vishnu, it's about the response. We have the source address of the machine, and the destination address is actually 239.1.1.1.1, right?
Mhm,
So when it reaches the router,
mhm.
that the router is not the destination, right? So
Absolutely, you
what
are right.
happens to the backend? Yeah.
Yeah. So basically, see, it is very, and I am amazed to see that whatever question asked in the Hindi class, right? I am getting the same question, and it is really interesting that you guys have that. So you are absolutely right about the query. Sorry, the report message is going towards 239.1.1.1, right? First thing first, you need to understand, Mr. Burak, could you be please on mute?
Sure.
Thank you,
Mhm.
thank you. So basically, when this report message goes to the destination address of 239.1.1.1, and when it reaches here, you are absolutely right that this is not the destination, right? But what I am trying to do from this message, actually, this message contain inside an IGMP message which says, yes, I am interested in 239.1.1. But actually, I am sending this message to this address. And now, just try to understand router for router, this is the one who is generating these IGMP messages, right, Mr. Arun?
Yeah.
So it means that it has complete information about 239.1.1.1. Why? Because at the first place, he has this message from source. How it get it? We need to discuss it, right? But we are presuming that RAR2 has 239.1.1.1, right? And because R2 has 239.1.1.1, that is why it is initiating the IGMP, right? It is initiating the IGMP query. I totally agree with you. But when this message, the report message received on 0/2 interface, right?
Hmm.
Believe me, router knows that it is for me. Why? Because at the first place, it has initiated the query message. So here,
Now,
yeah, go ahead.
yeah, I would say, instead of 239.1.1.1, we can use 224.0.0.2, right?
Definitely,
I
we
mean,
we could have we could have used it. And
okay.
basically the leave message, whatever I'm going to explain you next, right? That is going to do that. We
Okay.
could have done it. And right now, I do not have the answer for your why, but definitely it's a great question. We could have used it, right? But basically here, your report messages, whatever we have inside this 239.1.1.1, they are going into they are going towards the same address, right? Maybe I do not want to, what we can say, give wrong answer for that because I do not know about it. But maybe we can discuss, because this topic will go to tomorrow also. But I have noted down your
Okay.
question and I will be definitely replying you tomorrow, right?
Okay. Thanks.
And
Thanks.
if we have done it this way also, I think there shouldn't be any problem because router is the one who is going to get this, okay, which needs this. Okay,
Oh, got it.
all the way I got the answer for this, right? But still, I would say I will be explaining it tomorrow, because there is a concept of report suppression, right? If you have heard about membership report suppression, which we are going to cover anyhow tomorrow, we will be talking about it, right? But to understand that, we need to understand few more things. So just give me time till tomorrow, Mr. Arun. You are going to get this answer for sure, right? Mr. Rahul Kandhelwal, please ask your question.
So my question is the source keep on initiating or sending the packets for the multicast request? Because since the end host only listens and router is also listening. So if that is the case, the source keep on sending the packets, and if that's so, then what is the frequency?
Yeah. So you are asking how frequently these query messages are? You are saying this?
Yeah, how frequently not the query message, because query is generated by the router, right?
Mhm.
But source keep on sending the request to router, then router sends the query, right? Otherwise, router will not send the query.
No, 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 no.
So what?
Yeah. Can you repeat once again? Extremely sorry, I missed. I think I missed some of your some portion of your question. Can you please repeat it once more?
So what I'm trying to say is router is the one who's listening to the address of multicast,
Yeah,
right? And the source is the initiator,
yeah, here.
right? So if source is not sending any packet, then router will not generate any IGMP query.
You are right.
So what is the frequency from the source end? And if that is the case, then how the query is going to be from
Uh,
the router side?
I understand, but basically there is a lot of gap in our understanding, right? We have a huge gap that how this packet at the first place reach from this source to this router, because there could be hundred of routers between, right? Believe me, I cannot explain you that unless we get these things under our belt. So Rahul, this is a great question, but you need to hold this question until, I would say, fifth or sixth class. Okay, Rahul? But I will be definitely explaining you that.
Okay.
Yeah. So still now, my IGMP is not complete, right? Believe me. Why? Because Mr. Rahul has only answered uh, two things, right? One is that router is actually sending the query message, and basically hosts are replying with the report message. That is it, right? Now, somebody asked how much frequently this router is going to ask in this network, right? Suppose router is asked at 10:15 a.m. in the morning, and this host joined this group 239.1.1 at 10:16 a.m. in the morning, right? What is going to happen, right? How frequently it should ask, right? So there are two concepts or two terms I would like to introduce now. One is solicited response, and the another one is unsolicited response. What is the meaning? The meaning of solicited is, if I am asking you something, then you are replying, right? This is basically, this is a solicited response because I asked and you replied. What is the meaning of unsolicited? I am not asking you, and still you are conveying some message to me. That is unsolicited response, right? So right now, whatever we have discussed, right? R2 is sending query, and then these hosts are replying it back. It means that this is the solicited response because router asked and we replied. But sometimes it is very, very important that whenever this host join, they should not wait for the query message from the router, right? And Mr. Rahul is explaining this thing, right? Because somebody has asked Mr. Rahul, you have developed this IGMP protocol, but I see a flaw in it. Mr. Rahul is asking, what is the flaw? And they are saying, this is the flaw. Right, this router is asking at 10:15 a.m. and my host has joined 10:16 a.m. How frequently you are going to send this? Then Rahul is actually suggesting a way. If that is the case, then this host, whenever they join this 239.1.1.1.1, right, they should send a report message, and they should not wait for router's query message. As simple as that. And this is a solution, right? This is a solution for this problem. Very, very interesting, right? So whenever a host come online and if it joins the group, it is going to send a report message, and it is going to inform everybody that I am interested in 239.1.1.1. It will reach the router, and router will say, okay, I get an unsolicited reply, but I got it. It means that I need to send this stream on 0/2. Remember one thing, doesn't matter if we have 50 hosts here or 20 hosts here. If only one host is saying, router has to deliver this message on this complete network on this interface, right? After that, it is the responsibility of the switch how it is going to deliver. As simple as that. So Mr. Rahul has replied the another query that of course the router needs to send the query, and basically host needs to reply with the reports. Router host can also send the report messages that they are interested in this particular multicast address. They can do that, right? But now here is another question, because Rahul is all thinking about this protocol, right? How it should be. Somebody is asking that, Mr. Rahul, you have developed a pretty nice protocol. Believe me. But suppose at 10:15 a.m. And 10:15 a.m. this router is querying, right? And now at 10:20 a.m. both of these hosts decide that now they are not interested at all. They both are not interested at all in 239.1.1.1. If that is the case, then your protocol is going to fail because you do not have any rule for this, right? Mr. Rahul is saying, no, I have a rule for this too. And he's saying that if a host leave, right, it has to inform the router, right? And now this host has to inform the router. It means that it needs to send the packet to 224.0.0.2. It means that it is sending to all routers address, right? It is going to create a message. This message is going to be IGMP message in which it is going to write leaving. I'm leaving 239.1.1.1. Very, very interesting. If this host wants to send this message towards the router, it needs to put the source IP and destination IP. Source IP is going to be 10.20. Destination IP is going to be 224.0.0.2, which is the all routers address. And it is going to put, if it wants going to put this message onto this cable, it needs to put the source MAC as well as destination MAC. Source is going to be BBB, this host MAC address, and destination is going to be the multicast address corresponding to this address, right? This IP address. The message will be reaching here to this router. Router will be receiving it. Okay, I get a leave message, right? But router will not understand that whether it is the last host, right? It could be the case that there are 5 hosts in this group, in this network, who are interested in 239.1.1.1. Suppose if one left the group, if one is not interested in this song, if one is not interested in listening CEO's message, then what is going to happen? Remaining 4 are still there, right? So on the basis of one leave message, this router cannot decide that whether it has to stop delivering this stream on 0/2, right? And that is why whenever router receives a leave message, it is again query. Okay? Mr. Rahul is thinking a lot. It is saying it could be the case that there are 4 or 5 hosts. If one I am getting a leave from one, there might be other hosts, right? If that is the case, this guy is again query, and the remaining host is going to require, right? The remaining host is going to send the report message. And this way router comes to know, no, there are still some hosts there who are interested in 239.1.1.1. As simple as that. But suppose now there are only two hosts, one is already gone, it has left the group, and now it is also leaving the group. If that is the case, it is going to send the leave message towards the router. Router is again going to ask the query, and now there is no host in this network who is interested in 239.1.1.1. If that is the case, router safely say nobody is there who is interested in 239.1.1.1. If that is the case, I'm not going to send this stream on gray network. As simple as that, right? If things are going out of control, right? And that's the same feedback I get from Hindi class. It's too much. If it is getting too much, believe me, you just need to revise it. And I am seeing that Mr. Arun is asking a question. Mr. Arun, before your question, I just need to introduce some terms now, right? The official terms. This is the protocol which was developed by Mr. Rahul, right? Now I want to showcase you router when it receives the stream from source, it is going to decide whether I need to send it towards the green network or gray network or on both. Whatever the message IGMP message is creates, the name of this message is query, and the query IGMP message destination is actually 224.0.0.1, right? The report messages that was generated by this host to let Mr. Router knows that it is interested in 239.1.1. It is known as membership report. It is generated by host and it is sent to the group address, which is 239.1.1.1. All these addresses are destination addresses, guys, because multicast MAC or multicast IP address doesn't matter. It is always going to be the destination address. The third message, which is generated by this host to let router know that it is leaving the group, it is known as leave message, and leave message is generated by the host and it is actually towards a destination address of 224.0.0.2, which is the router address. As simple as that, right? These are some of the terms which you need to understand. Tomorrow, what we are going to do, we are going to again revise this. I would like to showcase you, although I have all these Wireshark capture ready with me, right? And believe me, if you see today's class, most of the things, whatever Mr. Rahul has developed, you are going to see them in Wireshark. Very, very easy. And now it is the question time, whatever coming to your mind, right? I can stay here for long period of time, believe me, but there should not be any question in your mind. Yeah, now, Mr. Arun, please ask your question.
Yes. Actually, the report message you mentioned that we'll be sending towards 239.1.1.1, but the switch doesn't know or where to forward the packet. So will that be a broadcast in the first
Yes,
instance?
yes. If this switch, and believe me, the next topic or the tomorrow's topic, we are going to run. We are going to learn IGMP snooping, and there I will remove all of your doubts. I will clear all of your doubts that how you are going to make this switch layer 3 aware or basically multicast aware. But believe me, if the switch
Okay.
doesn't know multicast, if you do not make it aware of multicast, it is going to broadcast all the multicast messages. Because
Okay.
it makes sense, right? Because switch creates a scam table on the basis of source MAC. And multicast messages, right, or multicast MAC address are always going to be destination. So you never will find a cam table which is having source MAC address or basically which is having a multicast MAC address. And if the multicast MAC address is not in the cam table, Believe me, switch is going to flood because for it is going to be unknown message. Right, Mr. Arun?
Yeah, got it. Got
Yeah.
it.
And I will give you the exact answer for you that why the membership report is 239.1.1 and not at 224.0.0.2. It is a
Yeah.
there is a reason for it. Although
Okay.
because you asked the question, that's why I came to another reason. But there is a process called report suppression, which is to make this LAN more efficient. I will talk about this tomorrow. Believe me. Okay, Mr. Arun?
Okay. Yeah.
Yeah.
Thanks. Thanks. Yeah.
Now, Mr. Rajsekharan Prakash, you can ask your question, please. Go ahead.
So this 224.0.0.2 is like it is used in multiple protocol. For example, HSRP also it uses this one. How router handles this kind of request?
See,
It has
yeah, when we say it is all about what is there inside this envelope. What is the meaning of this envelope, right? You are saying that 224.0.0.2 is also used in HSRP. I agree. It also used in IGMP, leave messages, the destination, right? But it all depends on what is there inside this IP header, right? See, HSRP protocol is going to create its own message, whatever the message it wants to send, maybe the hello, right? IGMP is going to create its own that I want to leave this. Whole sole purpose is what you are doing. You take this message, HSRP message, right? And you say it should go towards 224.0.0.2, whatever the source IP is, right? Maybe x.x.x. If a router is going to get this address, router is programmed to hear this address, right? Or to listen, to always listen on this address. Why? Because this is a router and TCP/IP developer says you need to open all the messages 220 which are coming at 224.0.0.2. Router will check the destination IP is me. I am the router. Then it is going to open this, right? Then it is going to decapsulate it. Then it is going to find it is HSRP. Okay, then it will be used for HSRP. But when it see the inside packet is IGMP, it will be used for something else. Mr. Prakash, did you get what I am saying?
Yeah, I got it. So,
But the
if you don't
confusion
mind,
is,
can
yeah, go
you?
ahead.
Yeah, just tell me after this, like step one, step two, step three, like a small review kind of thing for 2 minutes. Like how this complete flow work for.
Okay, okay, okay. Let's see. Let's see. We have,
Hello.
yeah. Can you hear me? Suppose we have two routers, R1, R2. Mr. Prakash, can you hear me? Guys, can you hear me? Can anybody please confirm?
Yes.
Yeah,
Yeah,
I have
Yeah,
bad
perfect,
Vishnu, we are able
perfect.
to hear you. Yeah.
Suppose basically we are running here HSRP protocol between them, right? And basically router 2 is also running IGMP, right? So there is a host which is sending a message, IGMP message, IGMP leave message. Okay. If that is the case, what is going to happen? It will create a message, I am leaving. First step, Mr. Prakash, it will say, I am leaving 239.1.1.1, right? And then what it is going to do, it is going to put an IP header on top of it. It is just like saying that you have an envelope of IP, and inside this you are having the IGMP message, right? Now you are writing source and destination IP. Source will be anything x.x.x and destination is going to be 224.0.0.2. This is the step number one. The packet will be received at R2. R2 will be opening this envelope. Why? Because 224.0, it is listening at 224.0.0.2 at this interface also, at this interface also, right? This is the multicast address. That is, it is locally significant here as well as here, because the packet, whatever are coming from here, it is not going to any other network because the TTL value is set 1 in them. And when it reaches to router, router is going to decrease it. These are not going to go anywhere. Second step, router will be seeing that, okay, this message is from me. It is going to remove this, and then it is going to see this IGMP leave message, right? And then it takes the decision on the basis of that. It is as good as opening this envelope and seeing this IGMP message. Mr. Arun, sorry, Mr. Prakash, you are done?
Yeah,
Now,
okay.
the second point. R1 and R2 are also running HSRP between them, right? And if they are, so because R2 can run OSPF also, it is, believe me, it is listening at 224.0.0.5 also if you run OSPF between them. There is no doubt about it. In case of HSRP also, suppose this guy is sending the hello message. First thing first, hello message is created. This hello message is going to be put into the envelope, means the IP packet source is going to be, maybe this IP address is y.y.y.y, destination is going to be 224.0.0.2. It is just like as pointing out that we have an envelope and we have inside this envelope HSRP message. This will go from here to here. If if it goes from here to here, R2 will open it, means it is opening the envelope and getting the HSRP message. See, totally, these two things are totally different processes. And router can handle multiple processes, OSPF, BGP, HSRP, IGMP, so many things, right? Mr. Prakash, did you get it?
Okay, done.
Perfect. There should not be any confusion in the mind with respect to this, right? Now, let's talk to Mr. Burak. Mr. Burak, you can ask your question. Please go ahead.
Okay, thank you, Vishnu. Will we talk about the different versions of IGMP protocol?
Yeah, very shortly. So basically, whatever I am talking about is IGMP version 2, right? IGMP version 3 has one more important addition, which is source specific multicast. We will be talking about, right? You will come to know the differences. Believe me, do not worry about it on your own. But whatever we are reading till now is IGMP version 2. Okay?
Okay.
Perfect. Mr. Rahul, you can ask your question. Please go ahead.
Yeah, Vishnu, the leave message goes to this address 224.0.0.
2.
Sorry, I was on mute. The leave message goes to 224.0.0.2, right? So in that case, the request, I mean the stream stop, right, for all the hosts which are listening for on 239.1.1.1. And then again, a query goes to all those hosts who are listening.
No, stream
So
is
does this
stream.
create
No.
any?
Stream is never ever going to be stopped unless router is absolutely sure. So router is having many hosts which are interested. Say suppose 10, right? Only one from one of the hosts it is getting the leave message. Suppose, right? It is not going to stop the stream whatever it was sending unless it is sure that this host is the last host, Mr. Rahul. And how it is going to sure? Because every leave, after every leave message, it is going to send the query, and if it get the query, then it is basically the continuation going on. It is never ever going to stop the stream. Okay, Rahul?
Okay. Okay. And also, does this leave message has the actual address of that multicast, like you have shown in this
Yeah.
packet
So basically,
239.1.1?
as I mentioned, see, just compare it with the ARP message, right? In the ARP message, what we do, we create a message which is having so many things. So sender MAC, sender IP, target MAC, target IP. But if we want to send it, we need to put a MAC address on top of it, right? Sorry, yeah, source MAC and destination on top of it. Just try to understand. In this IGMP message, I will be showcasing you on the Wireshark. In this IGMP leave message, it actually says, I am leaving 239.1.1.1, right? This is the actual letter created by this IGMP protocol. If you want to send it, you need to put IP address on top of it because it is the layer, it is created at layer 3, and then you need to put layer 2 header on top of it, right? So actually the message is this, in which everybody is interested. The router is interested in this message, but to deliver this message to this router, we need to put IP as well as layer 2. When this router receives it, it is going to say, okay, somebody want to leave 239.1.1.1. Okay, Mr. Rahul?
Yes. One last question.
Yeah, go ahead, please.
So this multicast address listening always required like the IP multicast routing to be enabled on the device, right? But while the other protocols like OSPF and other protocols are using the multicast address, but they do not require the multicast to be enabled on the device.
Very interesting question. But believe me, when you run, when you say, when you go on a particular router and you say router OSPF1, whatever, right? It means that you are enabling OSPF protocol on this router. You agree with me, Rahul? And if you are
Yeah.
enabling this OSPF protocol, believe me, what actually happens behind the scene, this router start listening on 224.0.0.5, and if it is a DR or BDR, 0.6 also. It happens. If you are running HSRP or if you do not, router, as I mentioned, router is running the TCP IP stack in it, and that is hard coded that you have to listen on 224.0.0.1 as well as 2, because you are host as well as router. Mr. Rahul, any doubt?
Yeah, I mean, the multicast has its own routing table, right? But
See,
in the
that is why
OSPF,
I get your question, but basically whatever I am saying is just one hop away. Whatever the IP addresses we have discussed till now, apart from 239, right? And that is what I am saying. We are going to discuss it when we understand multicast routing. Believe me, these are just one hop away. You do not need any routing protocol to be enabled to run them. If I am running R1, if I am running R2, if I am enabling OSPF on top of it, this guy and this guy start listening to 24.0.0.5 on its own. And you all know if a switch is there, then basically it is going to broadcast. If it is not, then if it is multicast aware, we need to explain how you are going to send it to 224.0.0.5. But because switch is not going to send this to an IP, it is going to send to an MAC, right? And that is why we calculate MAC address on top of it. We are not talking anything that how router 1, if it receive a message, how it is going to forward it to any other network. We are not doing it. Now, till now, we are, and that is why I'm saying we are just talking about layer 2 multicast. Mr. Rahul, now any doubt?
no issue.
No, I think your voice is saying some doubt is there. Think it through. I am here, right? What is the doubt? And we can answer. In the meantime, I'm taking question from Mr. Prashant Patilji. Prashant Patilji, please ask your question.
Vishnuji, let's say R2 is connected to two different network. So in this scenario, like yeah, it is connected to F fast Ethernet 0/0.
Okay.
Yeah. This is F/0/0 and 0/1.
Okay.
And we are two different network, and we have the host in A and B in 0/1 and C and D in 0/0.
Perfect.
Yeah. Okay, now all these hosts are they are listening to multicast traffic.
Yeah.
Now the hosts which are connected to 0/1, so they are sending a leave message because they want to listen to the multicast traffic.
Yeah.
And they will send the leave message.
So both of them are sending leave, huh?
Yes,
okay.
Both of them sending leave message.
Okay.
So does this router will delete the records for this
Yeah.
0/1 network?
Yes. For
and
example,
it is
going to say that now. So when first one send a leave, it is going to send query. Maybe the B is sending no, I want to receive. Now B is also leaving. It is sent to the send the query. Both has left. both have left, no reply is going to come. R2 understand there is no point of sending the multicast stream over FS0/1. If that is the case, it will not send it.
Okay, so basically it will delete the multicast routing for
Yeah,
the
basically
S/0/1
I
entry.
am not talking about it, because if we go into that, we need to understand few
Mhm.
more things. But I am in the layman terms, yes, R2 is not going to forward the multicast stream over FS0/1, because you are touching little bit of routing piece, right? Which we haven't explained till yet.
Okay.
Okay. Yeah.
Yeah. Thank you.
Now I would like to go again to Mr. Rahul. Rahul, did you think about it? If you have any slightest of doubt, please do ask. Because you just have developed this protocol, right? IGMP. You are the one. You should not have any doubt.
Yeah, I understood that the reserved addresses doesn't require any routing, and because it's one hop away, but the other multicast address just require routing.
Perfect. Yeah.
So that's the reason it is working, right?
Yeah. And if we do not worry, the last 5 or 6 class are totally based on routing. And this is the reason why people have little bit fear about it, right? I have to hide something, right? So that you can understand first the switching first. Believe me, when we understand the routing piece, and if you combine and see, it is going to make the complete picture. For example, when we started this lecture, this series, right, I said to understand multicast, if I break it, you need to understand L2 and you need to understand L3. Definitely whatever I'm question gearing today, mostly 40 to 50% are from L3 level, right? But believe me, let's complete L2. Till now, we have just see that how router decides on what basis where to send this stream. Believe me, there is another topic, how this right now switches is flooding everywhere, right? Let's make this switch aware of multicast, right? How we can make this switch aware of multicast, we are going to learn it tomorrow in the concept which is known as IGMP snooping. Very, very interesting and very, very easy to, but there should not be any doubt, guys, right? Although I will be showcasing you whatever we have learned about these membership reports, right? The queries, I will showcase you on the actual Wireshark. It is going to be mind-blowing experience, believe me. Having said that, thanks for being a wonderful audience. See you tomorrow at the same time. Bye for now.